Hi guys, I'm gonna do this extra review for you, but honestly, I think you're not gonna need it. You're gonna do great. All right, so what makes a statistical question? It's a question that will have a variety of answers. So it's something that has many answers. And you collect data. So for example, if I wanted to know the average height of a ninth grader, I would survey a bunch of ninth graders and I would record their heights, and then I would find the average height of a ninth grader. A statistical question would not be, how tall is so-and-so? That's a question that has one answer, how tall are you? Okay? But when you're gathering information, that's a statistical question. All right, so basically a lot of this stuff is going to be done on the calculator, and the most important thing is entering it correctly. So we go to the calculator, we hit stat, hopefully you can see this. I wanted to make this bigger, but it doesn't seem to make that bigger. The calculator's still the same size. Anyway, you hit stat, and then you hit enter. And you want to make sure you have your L1 here. If you don't, you want to reset the calculator, and that's second plus 712. You definitely want to know how to do that stuff. All right, so I'm going to type in the data, 12, 13, 14, 15, 15, 15, 18, 19, 20, 21, 22, 22 again, 22 again, and 22 again. I could have used a frequency chart. 1, 2, 3, 4, and then 24, and then 26. So again, the most important thing is that you type it right. So if I type it in, I would totally double check that I typed it right. So 12, 13, 14, 15 3 times, 18, 19, 20, 21, 22 should be there 4 times, and then 24, and then hopefully 26. All right, then you do stat, calc, 1var stats. Make sure your list is right and hit calculate. And then all this stuff we're just gonna copy down. So I'm going to copy the 18.75 exactly the way it is. On the test, it does say to round. SX, I'm going to go to the nearest hundredth, so I'm doing 4.27 because the 6 next to the other 6 tells it to go higher. And then minimum is 12, quartile 1 is 15, median is 19.5. Q3 is 22 and max is 26. And you would just basically copy all of this, okay? All right, so I might not be able to write it as clearly as you'd like, but again, 18.75, 4.27, 12, 15, 19.5, 22, and 26. Okay, what is the interquartile range? So the interquartile range is the difference between Q3 and Q1. So you would do simple subtraction. You would subtract. So what it does is it represents the middle 50% of the data. It's the box on the box whisker, okay? So I would subtract. Oh, actually there's a typo on this sheet, guys. This should say Q3, okay? So please correct that, all right? So I would just do 22 minus 15, which gives me 7. Okay, the range is max minus min, and to find that you subtract. And again, that's the high to low of all the data. So I would do 26 minus 12, which is 14. Okay? Now, standard deviation, there's a really long explanation for it, but it's like the, it summarizes how far things are away from the mean, okay? So it's basically a unit of measure of how far things are away from the mean. A unit of measure of how far things are away from the mean. If you've ever heard of a normal curve, that's where we use it. Okay, so it's kind of an abstract thing. We don't make you calculate it by hand, but basically it's the distance from the mean. Distance from the mean, okay? Average distance, I'm gonna say average distance from mean. I don't want to take away from the mathematical definition, but I don't want to get too complicated for you. So basically, you use it as a unit of measure. So I would take the mean, which in this case was 18.75, and I go one below and I go one above, and that's where 68% of the data would lie. And we use that as a way of saying like what's considered like normal. So where's most of the data? Where's 68% of the data, most of it? So if I do that work, my lower boundary here is 14.48. My upper boundary is 23.02. And sometimes what we ask is like how many data points fall in there. And you could just go back and look at your data points and see how many fall in there. It should be 68% approximately. It's not going to be perfect because we also don't have a large data set. Okay. You have to be able to make a dot plot, a box plot, and a histogram. The dot plot, you just make a dot for every data point. The box plot, you're going to want to put it in the calculator and get those 5 numbers. So you want to get the minimum, Q1, Q2, Q3, and the maximum. Okay? You have to be able to read this. So here, this would be at 12. This is at 15. This is at 19. This is at 22. And this is at 25. So that means that our min is 12. Our max is 25. You use max minus min for range. Our Q1 is 15. Our Q3 is 22. Use Q3 minus Q1 for interquartile range. And our median is equal to 19. Okay? All right, a two-way table. Basically, somebody asks 2 questions. Are you a boy or a girl? How do you get to school? So they summarize all that data into a chart. What % of students surveyed? So there were 135 students surveyed. How many of them walked to school? So that's 23 out of 135. So on your calculator, you just do 23 divided by 135. Enter, and then you do times 100. If you don't have to do times 100, because you can do that in your head, that's fine. And so we're going to say approximately 17%. Yep, got to find it. Okay, so 17%. What % of the boys, so there's only 67 boys, what % of the boys walk to school? So it's 13 out of 67. And you would do the same thing. 13 divided by 67 times 100. And you can also use the fractions. So that's 19.4%. And again, on the test, I do tell you what to round to. So 19.4%. Okay, 2 variable statistics. You have to be able to make a scatter plot, all right? So this might be hard for me, so I'll post a key just because it would take me a little while to make it, and I cannot make it. Well, let me try. I'm trying to make it smaller. All right. So I'm going to put the first test here. It might be a little sloppy. And I'm going to put the second test here. Actually, I'm going to stick with skipping it because this way you don't have to watch. You know how to make a scatter plot. And I will post a key. I just said it's going to be sloppy. Okay, so you hit stat, enter, up, clear, enter your data. So I'm going to enter 56, Yeah, see, this is why. It takes me so long. I'm so much better at my hand calculator. 75, 61, 61, 67, 72. I know you're all probably done entering and waiting for me. 62, 61. Scoot over. 21. Oh, not so good. 39. I hope the second test wasn't out of 100. 34. 21. 32. 24. 29. And 24. Okay, so again, double check that you entered everything right. I'm hoping I did. All right, and then you do stat, arrow over to calc, you do lin reg, L1, L2, calculate. Okay, so I'm gonna do y equals 0.59x minus 10.02. Okay, I did both to the nearest hundredth, and again, on the test it tells you. All right, so I have, almost wrote with the pen, y equals 0.59x minus 10.02, and then correlation coefficient r. The slope is positive, so r has to be positive. And I don't have diagnostics on, so this is actually a good learning moment. So you have to go to mode. You want to make sure stat diagnostics is on. So I got to go down here. If you don't get your R, your stat diagnostics aren't on. Stat, calc, lin reg, doing it again. Better get the same answer. But I got an R. So my R is 0.57, which is weak. So what I would say is, very simply, there is a weak positive or positive weak positive correlation between first test and second test. All right? Know your stuff. Good luck. Study hard.